Good day everyone, we are Group 8 and today we are excited to present our service learning video which focuses on creating a sustainable product that supports environmental awareness. Before we begin, allow us to introduce our team. We are a group of 4 students working together on this sustainable team project. I'm Kyrie and our group leader is Jack. Together with us are Fikri and Zin, each of us contributing to different parts of this project. We are all chemical engineering bioprocess students from the Faculty of Chemical and Energy Engineering in University Technology Malaysia. Our faculty strongly emphasizes green innovation, sustainable practices, and real-world engineering skills, which are all reflected in our project. And now, let's introduce our project. Our project is titled Turning Fruit Waste into Biodetergent. It focuses on producing a natural and eco-friendly cleaning product using lemon peels. Now, let's talk about what biodetergent is. A biodetergent is a natural liquid cleaner that is made by fermenting fruit peel, sugar, yeast, and water. It works as a multi-purpose cleaner that helps to remove stain, eliminate odors, and break down grease, making it useful for daily cleaning tasks. And you might wonder how we can actually use this in our daily life. Here are some common uses of our biodetergent. First, it's great for cleaning toilets and bathrooms. It helps to remove dirt and the smell naturally. Next, it can be used on kitchen surfaces to cut through grease and leave a fresh smell. And finally, it's also safe to use in cleaning of pet area since it's natural and chemical-free. Our project addresses 2 key issues. First, many chemical detergents sold today are non-biodegradable, meaning that they don't break down naturally and may end up polluting rivers and soil. Some also contain harsh ingredients that can irritate our skin or trigger allergies. Secondly, fruit waste from our kitchen is usually thrown away instead of being reused. Decomposing fruit waste in landfill releases harmful greenhouse gases and contributes to pollution. Our proposed solution is simple, low cost and sustainable. We use ingredients like lemon peels, brown sugar, yeast and also water to make a powerful natural cleaner through fermentation. This method produces no harmful byproduct and is very easy to do at home. To make the process even more eco-friendly, we use recycled plastic bottle to hold the fermentation mixture, which reducing both food waste and also plastic waste at the same time.
Now I'm going to present for the impact of this project to community and environment. So in terms of SETB 6, which is clean water and sanitation, it reduces the use of chemical-based detergents that pollute water systems and it helps prevent water contamination by replacing synthetic cleaners with natural alternatives. In terms of SETB 12, which is responsible consumption, it promotes the use of homemade low-impact cleaning products. It reduces waste by converting to convert fruit peels into useful products, and it supports zero waste practices through use of recycled plastic bottles. As you can see, we have fulfilled 2 out of 17 SDG, or known as Sustainable Development Goals, as shown in the figure. And how this project impacts the community is, it is safe to use for homes, schools and public places. It can be promoted in local workshops or eco-awareness campaigns.
Hi, my name is Jack. So now I will show you how to do the biodetergent by DIY. Okay, so let me introduce the ingredients we need. The first one will be the lemon slices, which the flesh is completely removed. And the second one will be 100 grams of brown sugar. Then the next will be the yeast, 1 teaspoon of yeast. So you can take one, just 1 teaspoon of yeast. And the filter net, the funnel, and any plastic bottle, 1.5 liter. Okay, the first step is to put the lemon peels, lemon skins into the bottle. By the way, I forgot to say this bowl has 3 lemon in there. So I cut off the flesh and leave the skin as sustainable. So 3 lemon is needed. Now we use the filter funnel. Use the funnel to put in here. So we can put in the next ingredient, which is the brown sugar, 100 grams. So I put it inside. And the last ingredient will be 1 teaspoon of yeast. You can buy it from the supermarket or anywhere. Just make sure it's put 1 teaspoon of yeast. Okay, so now we have add all the ingredients. We take out the funnel. And we add the water until this level. Okay, add the water about this level. Then we close it with the cap. Then now we need to shake thoroughly to make sure the sugar and the yeast are dissolved together. So just shake. Okay, as you can see, the sugar is dissolved into the water already, so you cannot see any residue in there. So only the lemons is in there. Okay, now so after we have done all the steps, now we have to wait for every 2 days to open the cap to release the gas. But before, there is one need to pay attention, which is the cap shouldn't be closely shut. So at this point, you need to allow the gas from inside here to gradually flow out. Otherwise, it might get exploded because you need to put about a month, 4 weeks. So after you tightly shut the cap, you open it by a quarter until half, like this. So when you squeeze it, you see you should remove the cap. This means you did not shut the cap very tight but loosely, so you allow the gas to escape. Otherwise, it might explode from time to time. So this is one of the precautions you need to pay attention. So yeah, so this shouldn't be tightly shut, so just loosely open like this. Okay, assume this is 2 days later. So now you need to open the cap. to release the gas. And after that, you shut it back again, close tight, then open by a quarter, turn by a quarter or until a half, like this. Okay, and leave it in a cold shaded area. After every 2 days, about 1 month or 4 weeks, then you can pour out the liquid inside into a container. Let's say it's here. Pour out. Then the liquid here, by using a filter of course. So you filter out the liquid. Then the liquid here will be your biodetergent, which can be used to spray the spray on the dirty surface to clean the oily surface or anything. Yeah, but need to wait for 1 month. So you need to remember to put in the cool shaded area. So that is all for the biodetergent tutorial. Thank you.
The fundamental involved in our project is reaction engineering, which is fermentation. We do the batch fermentation in 1.5 liter of water for 3 weeks. The reaction controls involved in our methodology of project is the first, the periodic cap opening for the 2 days, every 2 days for the first 2 weeks. It releases the CO2, preventing the pressure build-up within the bottle and maintaining the microaerobic conditions in the bottle. The temperature control also involved. The bottle is placed in the cold shaded area, which is around 25 to 30 degrees Celsius, to optimize the yeast activity without the external heating. The reaction kinetics involved is the duration of the fermentation, which is 3 weeks, allows the complete fermentation and enzyme reaction, which is the breakdown of pectins and liquids in pills. The next fundamental involved is downstream processing, indicating the product recovery. In our methodology plan, we did a solid-liquid separation, which is straining. It removes the undigested solids, yielding a liquid enzyme-rich biodetergent. To stabilize the final product, after the straining, we transfer all the filtrate to a clean bottle to minimize the contamination and extending the shelf life of our biodetergent. Our project is sustainable because we just use a low-cost waste, which lemon peels are used as our main ingredient, and the minimal equipment such as plastic bottle and empty container, with adding some yeast powder and the brown sugar as a neutral medium only. This aligns with the circular economy principles. The final biodetergent produced is also biodegradable and eco-friendly. Now I will introduce about the economic analysis of our project. Now I will introduce about the initial cost calculation. We start at year 0. It is assumed that one batch of the biodetergent, which is 1.5 liter, can last about 2 months. So for 1 year, we need to prepare total 6 batch of the biodetergent. So the total materials and apparatus cost is 55 ringgit 50 cents. Next is the yearly cost and selling price calculation and also the payback period calculation. Initially, since we have purchased some apparatus, which are funnel, strainer, and also the empty container. They can be reused for all the next batch, so starting at the year 1, we do not need to purchase them again. To show the non-return payback, we use equation 1, which is MP equals to P over NCF. The MP is a payback period. So 55 ringgit 50 cents divide the 45 ringgit 98 cents, we get 1.209. We assume that 2 years, so the payback period is 2 years. So, as conclusion, by addressing the problem of chemical pollution and food waste accumulation, this project provides a sustainable solution by converting food waste into eco-friendly biodetergent, contributing to several sustainable development goals, SDGs, such as responsible consumption, SDG 12, and clean water, SDG 6. As a result, the net cash flow per year is 45 ringgit 98 cents with a short payback period of 2 years. This project not only demonstrates the environmental and economic viability, but also promotes green innovation and circular economic practice within the community.